What I have here is a different type of software. Once again, this is the Mitsubishi software called GX Developer. Again, it comes in all different kinds of flavors. But the basic software, again, on the left-hand side has a file structure. You have basically the program name, which I named it count. You have the main program, which is the ladder logic here to the right. You have what's called device comments. This is where I identify everything that's going to be used. All the individual screw terminals can be identified as to what is attached to them. So device comments. Parameters right here show us about the PLC, memory capacity, and just the details of the PLC and the communications. Device memory is going to be the amount of memory that's actually being used in the specific memory locations. So this can be very useful when it gets down to some of the troubleshooting. Now we look on this one so far, and what I have on the program, the ladder logic on the right, looks kind of familiar. Now every one of the softwares I've demonstrated so far has used the same format, relay ladder logic. There's a lot of similarities in here, guys, but also there's a lot of differences. One of the differences will be the file structure on the left. The other difference will be the toolbars up here on the top. You have the standard Windows toolbar on the top, then you have all the function toolbars. And this is what's going to be different from every individual PLC, is the function bars. Everybody's going to have slightly different toolbars, different locations. They might even call these things different names. They might have different symbologies, different types of graphics, but every one of them are going to operate the same way. The most common structure you're ever going to see or find is relay ladder logic. Now, looking at the logic right here, if I go up here to line number 1 or line number 0, here I have terminal, screw terminal X0, and I have connected to it what I'm calling a stop button. Now that button's a normally closed contact in the field, but I'm using a normally open contact in the program. The close button in the field will activate that contact. Connected to terminal number 1, X1, is going to be a momentary push button that is normally open. So I push that button right there. That's going to send logic to a counter. Here we have a bracket command that's identified as C0. In this case, C stands for counter. This is counter number 0. Okay, I'm going to count to the number 6. K is a memory location that holds the number 6. On the next line down, we have a special command that's going to be a bracket. In here I can put a lot of different stuff. We have greater than, equals, counter 0, K1. So this is going to compare the counter 0's accumulator against the number 1. When that accumulator is greater than or equal to 1, load 1 output, Y0 turns on. Whatever is attached to Y0 will turn on. This M0 here is a contact from a binary. When that binary activates, contact opens, output turns off. And again, a binary be a virtual relay. Next line down, we have the same bracket command again. Greater than or equal to number 2. We're comparing counter 0's accumulator against the number 2. This turns on terminal Y1. Load number 2. This one again has a binary contact. When this binary contact activates, it shuts that load off. Well, next line down, we have the bracket command again. Greater than or equal to number 3. Counter 0's accumulator. Turns on load 3. Next line down, we have greater than or equal to 4, and this turns on a binary. This time they're labeled as an M. So when this output turns on, this contact right here will open. We look on the next line, greater than or equal to 5. This turns on a binary. When this contact opens, it turns off this load. And then on the bottom line, here we have equals the number 6. And this will reset the counter back to 0. So the graphics are a little bit different in the different types of softwares, but the softwares all work basically the same thing. Now I'm going to write this to the PLC. So I go ahead and push the write button. All I really need to do is write the main program, and I click on execute. Okay, now it's giving me a warning that says I'm going to be writing this while the PLC runs. We always got to think about what we're doing before we do it. It's going to tell me the PLC is going to stop. So can we stop it safely and run it? Yes. In most cases the answer is going to be yes. So now it's complete. Well, we do that right there, and I'm going to come over here and I'm going to go into the monitor modes, find my monitor. There's my monitor. Now, every place that's highlighted blue, all those areas are activated. So my closed push button right there, X0, is highlighted blue. That is currently a 1. It is activated. If I push the button, it deactivates. I push the button again, it activates. The two close contacts, M0 and M1, are activated. They are currently binary 1s. Now, when I push the button right there, X1, that's going to turn to a 1 and energize the counter. The counter turned from 0 to 1. The next line right there activated and the load energized. I release the button, that button's back to a 0. Now I push that same button again, and the next line is going to turn on output Y1. I push the button again, and Y2 turns on, or load number 3. But now I push the button again, it energizes relay M0, or binary M0. When that contact energizes, the M0 contact on the above line opens, turn into a 0. So the highlights identify what is true, what is false, activated, deactivated, 0, 1, any way you want to understand it. It does activate, and it does show us what it is. So now I push that button again and it activates the next one, M1. Contact above de-energizes. Now when I push the last button again, it's going to reset back to 0. So it resets back to 0. So right there, it's not as complex as it is. It's all relay logic, no matter whose make or model of PLC we're working with. It's just some softwares are drag and drop, some are keyboard oriented, some are easier to use than others. What I'm going to do here is close this project down. So I'm going to come over here to project and close the project. We'll go ahead and save that project as is, and we're going to start another project. Okay, what I'm using is a little FX CPU, and we're going to have a ladder diagram, and we just hit the OK button. Well, right here on the ladders, it opens up with a blank ladder, giving me only one rung with the word end, and the word end has to be on there. But now my commands right here for programming are all up here on the top, and these are basically how you can say keyboard oriented. F5, Shift F5, F6, Shift F6, F7, F8, F9. Okay, you get the idea on how that works. Off to the left we have our program file structure, programming, what gives us a generic list of what we're using. Now what I'm going to do is I'm going to start out right here by clicking on, wherever I put this box, this is where the contact's going to go. So I'm going to go ahead and click on my F5 or normally open contact, and it opens up an alternate contacts menu. With this menu, I can change this to any kind of a command I want, but I have to be able to type in a valid address. So I do need to know as to what is connected to what terminal, what device is connected to which terminals, and the logic I want to follow. So I'm going to use the terminal here, X0. I have a normally closed push button attached to that one. Well, right there it created its own line. But look, there's a blank in front of that line. We have to connect that line. So what I'm going to do is come over here and add a line, which is F9. So I just created the line to connect it. Now, right next to this, I got to put another push button, a normally open push button. So I click on the X5. I want to use my button number X1. I have a normally open momentary push button attached. Now, I also want to put on an output. So let's leave this output as a Y. Y0 is my first output, and it completes the line. But now, just like on some of the other softwares, we got to draw a branch, and it doesn't want to draw a branch by itself. So I have to put a box next to where I want the branch to go down, and I go ahead and click on the Shift F9, which is a line down. I move the box. Again, it draws the line to the left of the box. Right here I add the open contact, and we address it to the output, Y0. Well, there we have it right there. We created the first line, a simple start-stop station. The end rung is still present, but now this is gray. It will not work. If I try to download now, it just erases itself. With this program, we have to convert it from a graphic language to a language a PLC can understand. So now we have to come up over here to the word convert, and we got to click on convert, which is technically F4 on the keyboard. And once I click on the F4 convert, now this will actually run. But let's do this. Let's come over here to the left and add some comments. If I open up my comment file, X0, I'm going to put this as a stop push button. X1 was my start push button. Okay, we change the devices to Y0, and this would be load 1. Okay, we just added our comments to that. Okay, we go back to the program, the main program, nothing happens. But if I come up over here to these pencils, now it shows me my comments. Now I'm going to go ahead and write this to the PLC. Batch monitor, device test, write to the PLC. We only really need to write the program. We execute. We follow the instructions. It gives us several warnings. Now that it's completed, we close down the communications menu, and we can actually go on to monitor. Monitor mode shows me what's live and what's not live. My stop push button is now closed. My stop push button is now open. Stop push button is closed. I push down the start push button. That energizes the output, Y0. Y0 latches on. The circuit's holding. So we can create holding circuits. We can create virtually any kind of circuit in a PLC that we can with relay ladder logic or hardwired controls. But the big difference is there's a lot of the rules for hardwire controls that do not apply to the PLCs. There's a lot more capabilities.